Well, hello and welcome. It's time for us to sit down together and go through another homework set. We're going to be doing questions 25 to 30 right here. If you have just the need to look for a particular question, right, please scrub through the video and find what you need and then get on with things. I don't assume that you need to know all of this, but if you're struggling, it's awfully nice to sit down and go through a problem set once in a while. So question 25 says, a study was done for a vitamin supplement that claims to shorten the length of the common cold. The data the scientists collected from 10 patients, wow, that's a huge study, not in an early study as shown in the table below. Interesting. So you can see we have just 10 values, and the values are the number of months that the supplement was taken, number of months taking the supplement, and the number of days that the cold lasted. And we are supposed to describe the association, model the data with a line of best fit. Remember, our technique right now is we're just kind of looking at the data and we're picking a line that we think fits the data well. According to your model, how many days do you expect a cold to last for a patient taking the supplement for 1.5 months? C says calculate the residual for 1.5 months, interpret the residual in context of the problem. And then D says interpret the Y-intercept in context. What does the Y-intercept mean for this problem? Well, let's jump over to the Desmos Ease tool and take a look at what they've got set up for us. Oh, that's beautiful. It really is. One of the things I like about both Desmos and GeoGebra is when you bring your cursor down and you hover it over the x-axis or the y-axis and you hold the shift key down, what happens is when shift is active, I can click and I can expand this. So it's much better, right? My data is only going to 2.5 months. To kind of stretch this out gives me more room to look at the data. And I think I've got some off the screen, so I can click and I can compress this one a little bit so I see everything. There we go. Look at that. That's great. Now, as we're doing right now, right, we're just kind of estimating a line of best fit by looking at the data. And you can see they've given us 2 points here. Let me put this back over here. And what we're going to do is just grab these points and try to find a reasonable line to fit the data. And I'm thinking, I don't know, I could try and get really nice numbers. That would be nice to get, but actually that's not a bad line also, right? So let's go with that. And I think probably what I want to do is I'm going to copy this and go put it in my notebook. Okay, so we've got our graph nestled nicely into the notebook here. Some of you I've noticed have been kind of grabbing screenshots like this and then working on it in docs. Some of you I've seen actually print these up and then put them in your homework in your composition notebook and snap pictures. Those are all great strategies, whatever works for you. I've have thrown this into OneNote where I can ink. So what we're going to do now is we're going to find the equation of this green line. This green line is what's going to be the model, right? My model for the data, and I'm going to use this model to make predictions. So the first thing I needed to do to figure out the equation of this model is I need to calculate the slope. And I remind myself always that the slope is how much y changes divided by how much x changes. And for this particular problem, it looks like I'm going to just go ahead and write 5 minus 1 for my change in y, right? You can see this is where the y's are, and it changed 5 minus 1. And then for my change in x, I'm going to write 0.4, and I'm going to subtract 2.6. So my numerator ends up being the number 4. My denominator is going to be negative. In fact, I think it's negative 2.2. Negative 2.2. So I could finesse with that a lot. I think in this setting, I'm just going to go ahead and take 4 and I'm going to divide it by negative 2.2. And when I do that division, it is this repeated decimal, so that's okay. So I get that that is equal to 1.81, and the 81 repeats, but it is negative. So there is my slope, right? The slope for the model of this data, negative 1.81 repeating. Now I need to figure out what my Y-intercept is, or the thing I talked about in class today, I could use the point slope form also. I think I might use the point slope form. So remember, the point slope form of a linear equation is you need to know both the slope and a point. And if you know a point and a slope, you can do this. It's basically y minus the y value at the point that you know, right? Because we're going to know a y, and that's going to equal the slope m times the quantity of x minus the x at the point that I know. So this will be fabulous. I'm going to use, it doesn't really matter. I'll use the second point up here. So I'm going to use 2.6 for x, and 1's going to be my y. So I'm going to write y minus 1 equals, boy, I don't like that, negative 1.81 repeating. And then I've got x, which is 2.6. No. X is the variable. I got to write x. And then I go minus my x value from the point that I know. There we go. There we go. So this is my model. I should clean this up, and I will clean this up. I'm going to do two things. I'm going to add 1 to both sides. So I'm going to have this plus 1 over here, but I'm also going to distribute and collect like terms. So this is going to be negative 1.81 times x minus, now I have to take the negative 1.81 and multiply that by negative 2.6. So times 2.6, that gave me 4.72 repeating. And then when I add 1 to it, it's going to give me 5.72. So this is 4, when it's positive now, 4.72 repeating. It's positive because I multiplied a negative 1 times this negative 2.6. And then when I add the 1 to it, I get my final model is y is equal to negative 1.81 repeating x plus 5.72. And that's repeating also. All right, so fabulous. We have a model that attempts to tell us what's going on here. Let me grab a copy of that, and let's go back over to the questions. Okay, there's our model. So let's see. So first of all, it says describe the association. Okay. Let's go look at the graph to describe the association. When I look at this, I would say first of all, it is, I would say it's linear, right? I would say its shape is it's a line. So that's an important thing. Shape. So this is my description of it. Shape is a line. It's linear. Direction, it is decreasing. As my x values get larger, my y values are getting smaller. Outliers, I don't think I would say none. Outliers, none. I don't see any here. And then the other thing, let's see, shape, direction, outliers, and strength. I could talk about the strength. STRENGTH. It's a small data set, but I'm looking at it. There's some variation, especially with these particular points in here. They're a little further away. I would say I would still call this a strong association. Strong. I wouldn't call it very strong, but it looks like it's a pretty strong association based on these just 10 values. It's going to be cool when we can quantify these with statistics. Let's keep going. So that is my description of the association. Check. B, model the data with a line of best fit. Got it. According to your model, how many days do you expect the cold to last for a patient taking the supplement for 1.5 months? Okay, so it's important to remember what the model is telling me, right? The model The X value says how long you're taking the supplement, and the Y value tells you how, what was it, how, what it says right there, it says number of days the cold lasted. So if I want to get out of here, if I want to, I'm asking my model, hey, for 1.5 months, if I put 1.5 months in there, 1.5 goes in, tell me about how long my model says the cold will last. So let me grab my calculator. I did not use the repeating decimal, so I just used 1.81, negative 1.81, and the positive 5.72. But when I plugged in an X value of 1.5, right, my model gave me a value of 3.005. I'd say pretty much 3. So yeah, I would call that 3. So I would just say, hey, 1.5 predicts that your cold will last for 3 days. So it says, how many days do you expect? I would expect the cold to last 3 days. So I've written, I expect a 3-day duration for the cold. The next it says, calculate the residual for 1.5 months. Okay. So if we go over and look at our graph, right, 1.5 months you can see is right here. And it's very clear that there's a bit of a residual there. You can see this is the value that the data point says, but the residual is the difference between those. And what we're going to do is figure out what the length of that line segment is, how big that residual is. And to do that, we need to know our predicted value. And if you recall, we just found out the predicted value because we plugged in the 1.5 into our equation, and the model, this red line, said 3 days, right? 3 days. Now, this data point, if I look over here at the y-axis, the data point it's at 1.5 days, and you can see it's 2, that would be 3. It's about 3.25, about 3.25. But I got something even better than that. I can just go look at the original data set. Oh, there it is. So in the data set, when I put in 1.5, the actual value was 3.3. So I can come over here and I can say, well, this point was at 3.3 days. And if I want to calculate the residual, and by the way, your mileage will vary. Please be aware of the fact that this is based on the equation that I came up with. I'm just talking about the process here. Your answer can be different. In fact, if your answer isn't different, I'm kind of like suspicious, right? Because it should be different. But I'm going to come in here, I'm going to say, okay, so the residual is the actual value that was recorded in my data table minus the prediction the model made. So I would say the residual is 3.3 minus 3, which is 0.3. And notice it's a positive value, right? 3.3 is above the line. So when I take the 3.3 and I subtract what the model said, I get 0.3. So that means this residual, right? The residual here is 0.3 days. We are asked to interpret the residual in context of this problem. If I'm looking at this, I would say that the residual means that my model predicts the cold would only last 3 days. That's right. That's what my model predicts. But for that particular person, that data point, their cold lasted for 3.3 days. So you can see my model is under predicting the duration of that cold. Okay, and then the very last question, it asks us to interpret the Y-intercept in context. Okay, so let's take a look at this, the Y-intercept. So this means, and it's off the screen there, but I think in context of this problem, it would mean that you have not taken this supplement at all. So what we're looking at here is about how long you could expect the cold to last with no supplement being taken, right? And if I go back and I look at the actual graph, it's it's below 6, right? I guess this is 5, so it's around 5.75 days. So that's what that means in context of this problem. If you don't take the medication, or if you're not taking this supplement, you can expect the cold to last about 5 3/4 days. Wow, 25 was certainly worth the price of admission here. Let's see. A line with a slope of -2/3 passes through the point -12, 16. What is the equation of this line? What is the x-intercept of this line? Well, that's interesting. The x-intercept, that's going to be a bit of thinking, huh? But let's come up with the equation. I'm not going to use the point slope form for this. I'm going to use the technique we've been using in class. So I will start with y is equal to mx plus b. I've got an x value and a y value from this point that I was given, and I'm going to plug those into this. So I'll write 16 equals my slope of -2/3 times an x value of -12, and then I have plus the b. When I multiply -12 times 2/3, right, 12 divided by 3 is 4. So I end up with -2 times -4. So that's the number 8. Yes, it is. Yeah, -2/3 times 12 is 8. Yeah, because it was -2/3 and -12, it's positive 8. So 16 equals 8 plus b. That means that if I take away 8 from both sides, b is 8. So now I have my slope parameter of 2/3, and I have my y-intercept parameter of 8. So I can write y is equal to -2/3 times x, and then plus, I don't know why I put x in parentheses, times x, and then plus 8. Now, we know the y-intercept is the number 8, and we're not asked to give the y-intercept because I already know what that is. They're asking me to give what the x-intercept is. And if I have just a minute to think about this, right, the y-intercept occurs right there. There it is, right? The y-intercept occurs the moment that x equals 0. So when x is 0, I get the y-intercept. And the x-intercept, I'll use a green dot, is right here. And the x-intercept occurs the moment that y is equal to 0. So if I want to figure out the y-intercept, nope. If I want to figure out the x-intercept, that's what's crazy is it feels this is the x-intercept. If I want to know the x-intercept, I have to set y equal to 0 and solve for x. And if I want to know the y-intercept, I would set x equal to 0 and solve for y, which would be easy because I just get 8. So let's take that equation, and I will just write it over here. Y is equal to -2/3 times x plus 8. And I'm going to place the value y is equal to 0. So I'm going to put y is equal to 0. And that's going to equal -2/3 x plus 8. I'm going to add 2/3 x to both sides. There we go. And what the heck, fraction buster, I'm going to multiply by 3. So this is going to become 2x equals 3 times 8 is 24, right? 16, 17, yeah, 24. And divide both sides by 2. X is the number 12. So x is 12. The x-intercept happens when x is 12. And of course, y is 0. So I can say my x, the equation of the line, this is the answer to part A. This is A. And my answer to part B is that my x-intercept is the point. I can write 12, comma 0, right? So my x-intercept happens when x is 12. And of course, y would be 0 there as well. On to 27. 27 says, for each area model, fill in the missing parts. Write an equation showing that the area as a sum equals the area as a product. Wonderful. Wonderful, wonderful, wonderful. So if I'm looking at this, again, these values inside of here are obtained by multiplying the length times width. And if I've got this value down here is x, and my product is xy, that means this would have to be y. It has to be y. And if that has to be y, and this is positive 3, 3 times y, gives me 3y. And the final one is if this is y squared, then, and that's y, right? Since this is y, then this would have to be y also. And I don't know why they wrote the +3 up there. I would have the 3 down here. So I would say, I'm going to write the area as a length times width, right? So the area's length times width would be simply y times x plus 3 plus y. And that is equal to xy plus 3y plus y squared. You can see each of those in the area model, right? So when you multiply y times the trinomial x plus 3 plus y, you get xy plus 3y plus y squared. Beautiful. And b. Okay, so, wow. Okay. Interesting. Not giving me a lot here. Although I'm just gonna say if this is x squared, I'm gonna say this is x and this is x. And I actually think I could do that different ways. I think with like fractional or negative exponents, I could do that in different ways, but I'm not going to do it. I'm just going to go, that's x and that's x. And if those are x and this is 8x, that means that this would have to be the number 8. And if they're telling me that this dimension here is 3, 3 times this 8 would give me this is 24. And then the last one there would be 3x. So if I wrote this out, it's saying that x plus 8, that's the dimension that goes up and down, times x plus 3, that's the one that goes left or right, would have to equal upper left hand corner x squared plus, I got 8, 9, 10, 11x, right? These are these, I got the 8x and 3x, that's 11x, and then finally plus 3 times 8 is 24. There we go. That's 27. 28. 28. Oh my goodness, there's six of them there, huh? Wow, okay. It says if f of x is equal to 3 minus the absolute value of x, and g of x is equal to 3x, 3 to the x plus 5, then calculate the value of, okay, so the first one, what do you get from f of x when you put in a -5? Well, that's cool. If I put -5 in there, that would equal 3 minus the absolute value of -5. The absolute value of -5 is 5, so this would become 3 minus 5, wouldn't it? And 3 minus 5 would be -2. So when 3 goes in there, I end up with -2. Next one, let's do B. Well, let's do F. We're right here. D. When 2 goes into there, okay, so if the number 2 goes in, then this is going to be 3 minus the absolute value of 2. The absolute value of 2 is 2, so this is going to become 3 minus 2, which is 1. So even though I've got the absolute value here, I keep getting these, I'm still subtracting, aren't I? Because I'm subtracting the results of the absolute value. All right, let's go to B. It says g of x, or g of 4 rather. Okay, so this is exponential. So this is 3 raised to the 4th power plus 5. Well, I happen to know that 3 times 3 is 9, times another 3 is 27, times another 3 is 81. I know that because I know that 9 times 9 is 81. So this becomes 81 plus 5, which is just the wonderful number 86. Right? Yeah, 86. And then it also says, what's g of 1? Well, g of 1 is fabulous, right? G of 1 is just going to be 3 raised to the 1st plus 5. 3 to the 1st is 3, so this is going to be 3 plus 5. And the last time I checked my calculator, it kept saying that was 8. All right, last two over here. Oh, That's great. They're f of 0. I can remember that because I was going to say the problem is I can't see the functions now, but I'm supposed to value f of 0. So this one is fabulous, right? Because 3 to the 0 power is just the number 1. So this is going to become 1 plus 5, which is 6. So I put in 0 to that function, I get 6. And the other one is when I put 0 into here, this is going to be 3 minus the absolute value of 0, which is just 3 minus 0, which is 3. So f of 0 is 3, and g of 0 is 6. So I can come over and write here, f of 0 is 3, and g of 0 is 6. Next, we're asked to solve a couple equations using the ever-popular fraction busters. And I can see that the first equation has 3 terms, 2 terms on the left and 1 term on the right. And the number 70, or if you will, 7 times 10, 7 times 10 will destroy these fractions or bust up these fractions. So let's fraction bust this. So if I'm going to put, I'll write it out. I'm going to have 2 times 7 times 10 over 7. And don't forget this whole thing's being multiplied by x. Okay, so I put 7 times 10 in that first term, and then I got plus 2, well, yeah, there was a 2 times a 7 times a 10, so that term got a 7 times 10, and that's going to equal 3 times 7 times 10 over the number 10. So if we look closely at what's happened here, right, I've brought in factors of 7 times 10 to the first term, 7 times 10 to the second term on the left-hand side, and then 7 times 10 to that term over on the one term on the right. So now I can look at the wonderful ones, right? The wonderful number ones. That's a 1, so it's gone. This term is going to become 20x plus 70 times 2 is 140 equals, this is a wonderful number 1, right? 10 over 10 is 1, so that's just going to become the number 21. What a nice looking equation. I've never seen such a nice looking equation. Let's take the number 21, and from each side of that equation, we're going to subtract 140. 21 minus 140 is, that's interesting. It's negative 119. So 20x is going to equal negative 119. And I'm going to divide both sides of that by 20. I don't think that's a nice number. Let's divide by 20. I'm doing it on a calculator, and it's not the worst thing. X is negative 5.95. That's great. Let's just stop right there. Now, checking that would be an appropriate thing to do, and it's not bad because all I have to do is multiply the 2.27 times that number and add 2 to it and just verify that it is the same as 3/10. I think I'm going to do that on a calculator here. I'm going to go times 2 divided by 7 equals, and then I'm going to go plus the number 2, and I get exactly 3/10. That's fabulous. Fabulous. Okay, next and final problem. No, it's not the final problem, is it? This is tough. So the number 50, it does have a 5 times another 5 times a, no, it doesn't have 2 5s. 50 is, 50 is 2 times 25. Okay, so 50 is a 2 times a 5 times a 5. That's the number 50. So I need 2 factors of 5. And oh, this is beautiful. 50 has everything I need because these are the factors of 50. I'm just taking a look at them for fun here, class. And it turns out that 50 has 2 factors of 5, which is exactly what 25 is. And 50 also has a 2 times 5, which is what 10 is. So it turns out if I multiply both sides of this by 255, what do you mean 255? A 2, a 5, and another 5, everything's going to go away. So let's do that. Let's just multiply everything by 50. In fact, I'm gonna take a chance. I'm gonna go ahead and I'm gonna write this as the number 50, but I can refer to it over here, and if I need help with identifying giant ones. So this is going to become 9 times 50 over 50. Okay, you got it, 50, plus 6x times 50 over 25. Okay, you got a 50, equals 3 times 50 over 10. And you got a 50. Everybody got a 50. So first thing I notice is that that's gone. 50 was 2 times 25. So I can bust this up and write this as 2 times 25. So the 25 is going to go away, and I'm going to be left, don't forget there's a factor of 2 here now. And then finally 50 divided by 10. Right, 50 divided by 10, that's 5 times 10. Actually, I think I like doing it the other way, but I still have a 5 here, I don't forget. I like it when I write 255. I think that looks better. But my answer here now, I've got a 9 plus, this is going to be a 12x, and that's going to equal the number 15. What a lovely looking equation. Let's take 15 and we'll subtract 9. 15 minus 9, I'm subtracting 9 from both sides. 9 from both sides. I took away 9 from that side, and when I take away 9 from the other side, I get 6. And then when I divide both sides by 12, I get 6 twelfths, right? Which is 1/2. So x is 1/2. That's wonderful. If it's right, it's wonderful. Let's see. This is kind of cool. So if I was going to check this, this numerator would just become the number 3. So I'm just going to ask my calculator, is 9 divided by 50 plus 3 divided by 25 the same? It's not. I'm wrong. I think I'm wrong. 9 divided by 50 equals plus 3 divided by 25. No, I'm supposed to get 3/10. I'm not getting 3/10 here. I'm not getting 3/10. So if I'm honest, I made a mistake. I did. Oh my gosh. That's mildly concerning. So you know what, I didn't like how that looked. So let me do this again. This pen's too big for this situation. Let me make the pen smaller. And I'm just going to write, so I've got a 9 times 2 times 5 times 5. That's 25 times 2. That's the number 50. Plus, I got 6x times a 2 times a 5 times a 5. That's the number 50 over 20. Oh, I see. I think I see what I did wrong. Maybe, no, I don't see what I did wrong. And then that equals 3 times 2 times 5 times 5 over the number, over the number 10. Okay, so 2 times 5 is clearly 10. So this became 15, and I did have 15. 5 times 5 is 25, and 2 times 6 is 12x. And that's, oh my gosh, so I was right? 15 minus 9 is 6. 6 divided by 12 is 1/2. But 1/2 didn't work, didn't I? Because 1/2, if I plug in 1/2 right there, this numerator becomes 6 times 1/2, which is 3. So this becomes 9/50ths plus 3/25. If I was to make these the same fraction, I go 2 over 2. So that'd be 9/50ths plus 6/50ths. Let's see, it would be 15/50ths, and 15 divided by 50. I was right the whole time. Oh, I'm so sorry. I was right, and I spent all this time trying to find a mistake that didn't exist. Well, what are you going to say? Things happen. All right, let's look at our last problem. Something about a bistro. At Jacques Bistro, they serve two size espressos, the small and the large. In a given day, they make X of the small drinks and Y of the large drinks. What do the following expressions represent in this context? Okay. Okay. They serve two size espressos, a small and a large. In a given day, they made X of the small drinks and Y of the large drinks. I don't like this question. I think that someone wasn't paying attention here. Let me look at something real quick. Okay, so I think I get what they're getting at, but I don't think they did a good job of it. So the S apparently represents the volume of the small drink. So let's say that this is maybe like, I don't know, maybe this is an 8-ounce coffee and maybe this is a 16-ounce coffee, right? So if that's what they meant, if you were to add S and L, that would be the total volume of the coffee, FFEE, right? And then in a given day, they made X of the small drinks and Y of the large ones. So this right here would be, well, actually, this is not the total volume of coffee. All S plus L is, that's just the volume. That's the volume of a small drink plus a large drink. So if that was 8 and 16, that would just be 24. That's all that is. Now, I am interpreting X and Y to be the numbers of each that they sold because that's what they say, right? So this is the total number of coffees. So like if you sold like 100 of these and 250 of these, right? Then you would have sold a total of 350 coffees. Now, this, right? If I sold 100 of those and each one was 8 ounces, 8OZ, and I sold 100 of these, then that would be the total ounces of the small coffees sold, plus this would be the total ounces of the large coffees. So this is a huge, I don't know, vat of coffee. This is the total volume of all coffees sold. Yahoo! That's exciting. That's a lot of coffee. That's like all of a sudden, like now, I think I can go to sleep. I had enough coffee. All right, well, that's been fun. It was real, but we all know that that wasn't real fun. But thanks for coming by, and I hope you found what you were looking for. I'll see you again later online.